of the variance in item 1 is shared with the remaining variables. And so you want relatively higher initial estimates to again tell you that you should include that variable in the analysis. There's no real rule exactly what you should include or exclude, and in my opinion, I think anything as low in the 20s when you're analyzing items is probably going to be good enough. Factor analyzing items, and that's one of the reasons why I chose to use an item data set, is when it's the toughest thing to factor analyze item level data. And it's telling me that item 5 doesn't share a lot. It only shares 16.5% based on a multiple regression analysis. But I'm still going to keep it in because the TAS20 has been used several times. It's been factor analyzed in the past, so I'm not going to throw it out. And then we've got the extraction communalities. And again, I think when you're analyzing items, anything as low as 0.20 might be considered acceptable. But we do have some pretty low ones here. I mean, this is only 9% of extracted variance that's been shared with the total solution. And this one here is very low, and we can see that there's something common here. It's with the EOT factor. So there's 3 factors in the TAS20: difficulty identifying feelings, difficulty describing feelings, and external oriented thinking. And we can see that the EOT factor is proving problematic, and I suspect that the anti-image correlation matrix that reported the measures of sampling adequacy on the principal diagonal, my hunch is that that's item 16, 17 were probably EOTs as well. But anyway, so that's the extraction levels of communality. Then we get the table of total variance explained, and we pay attention to this side of the table where we've extracted 3 factors. And we can see that the third factor doesn't have an eigenvalue exceeding 1.0, so it wouldn't have been included in the analysis had we used the 1.0 demarcation criterion for an eigenvalue to be included, whereas the parallel analysis clearly told us that there should be at least 3, and I ignored 4 and 5 because I was not confident that those would be real factors. We've got the percentage of variance accounted for by each factor. So there's a big whopping 26.9, and this is the unrotated solution, by the way. So if we're looking at unrotated, 26.9, and then the second factor is 5.4, and then 4.4 for the third factor. So there's a very precipitous drop. In total, 36% of the variance has been explained. And what SPSS does here is it's explaining it for total variance, which is a bit of a peculiarity. We're in factor analysis mode, and you'd think that it would only be common variance that we would be interested in understanding the percentage of variance of, but it really explains it in total variance terms. Everyone does that. All papers report that. It's argued. I've written a paper where I said that seems a bit bizarre. Here we got the rotated sums of squared loadings. So it's pushing and distributing the variance across the factors in a more evenly distributed manner, but it doesn't give us the percentage of variance accounted for or associated with each factor in the rotated solution. Maybe that's a bit of a disappointment. But it's more evenly distributed. So now I'm feeling like, okay, maybe there are 3 factors associated with this rather than one really big factor and 2 puny ones. It seems like the rotation is distributed more evenly. Here we've got the scree plot that we've already produced based on the parallel analysis. I'm not going to say anything about that now. Here we've got the factor matrix, which when you use a oblique rotation or use any type of rotation, I would argue that you wouldn't really pay a lot of attention to this. In fact, just try to make sense of this. It's very tough. We can see that there's one big factor. So this is the unrotated factor solution. There's one big factor. And they're all positively correlated, all positive factor loadings from each of the variables. So there's some pretty small ones at the bottom from the EOT. And then you try to make sense out of this, and it's not that easy. I can see a bit of a cluster here. There's the EOT factor here, I guess. But difficulty identifying feelings, difficulty describing feelings, I can't really see that in this solution, and that's why you should probably always ignore it. Here, SPSS is giving us the goodness of fit test, and that's unique to maximum likelihood estimation. You don't get that with principal axis factor analysis or alpha factor analysis. And this is it's testing, basically testing